Welcome to tonight's video on Unit 3, Part 3. We're going to talk about counting principles and then permutations and combinations. So there are simple counting principles, like how to count if a number of things happen one after the other. And for example, if you place 8 pieces of paper in a box, numbered 1 through 8, and you draw one paper at random, record its number, replace the paper in the box, then you draw a second piece of paper, record its number, and basically, finally, you add the two numbers. How many different ways can you obtain a sum of 12? Well, you could do 4 and then 8, 8 and then 4, 7, 5, 5, 7, 6, 6, right? Because you can get the same one twice. So here there are 5 ways to get a 12. But if you have a sum of 14, you could get 6 and 8, 8 and 6, 7 and 7. So there are 3 ways to get a 14. The same problem in example 2, except now you're not allowed to put the paper back. So what happens is that's going to eliminate the doubles because you're not allowed to draw the same one twice. So really for 12, you're going to have 4 ways, right? You're going to have 4, 8, 8, 4, 5, 7, 7, 5. And for 14, you'll just have 6 and 8, 8 and 6. So you have 2 ways. For example 3, determine in how many ways a computer can randomly generate 2 integers 1 through 12 whose sum is 6. So it'd be like 1 and 5, 5 and 1, 2 and 4, 4 and 2, 3 and 3. So there are 5 ways to generate that sum. However, if they have to be 2 distinct integers, that would eliminate 3 and 3, which would mean you just have 1, 5, 5, 1, 2, 4, 4, 2. So you just have 4 ways. So the difference is examples 1 and 3 have replacement, meaning you can get the same thing twice, whereas examples 2 and 4 are without replacement, meaning once you choose a number, you can't choose it again. The fundamental counting principle says that if you have 2 events, and you're trying to figure out how many different ways they can occur one after the other, you take the number of ways the first event occurs and multiply it by the number of ways the second event can occur. So for example, how many different pairs of letters from the English alphabet are possible? Well, the English alphabet has 26 letters, so the first choice you have 26, second choice you have 26, which would mean there are 676 pairs possible. A combination lock will open when the correct choice of 5 numbers, 1 through 20 inclusive, is selected. How many different lock combinations are possible? You could have the same number as many times. So there's 20 choices for the first one, 20 second, 20 for the third, for the fourth, and for the fifth. So basically there's 3,200,000 choices. All right, for number 3, in a certain state, automobile license plate numbers consist of 2 letters followed by 4-digit number. So, and the digits, remember, are 0 through 9, so there's 10 digits. So for the 2 letters, you have choices 26 and 26, and for the 4 numbers, you have 10, 10, 10, and 10. So when you multiply that out, you get 6,760,000 license plates that you can get. All right, the next one, telephone numbers in the United States have 10 digits. The first 3 digits are the area code, and the next 7 digits are the local telephone number. A local telephone number cannot begin with 0 or 1. How many different telephone numbers are possible within each area code, meaning local telephone number? So there's 7 digits, but the first one can't be 0 or 1, so there's 8 choices, but then after that, you have 10 choices for each number. So since there's 7 numbers, and the first one you have 8, and then after that you have 10. So you have 8 times 10 to the 6th, which is 8 million telephone numbers. All right. So that's the fundamental counting principle. Now there are special type of arrangements that you can have. One arrangement is what's called a permutation. And a permutation is when the order that the elements are in matters. So the permutation of n different elements is an ordering of the elements such that one element is first, one is second, third, and so on. So the order matters. So how many permutations of the letters A, B, C, D, E, and F are possible? Well, if you think about it, in the first position, there's 6 letters. Once you choose one for the first position, then you only have 5 for the second, 4 for the third, 3 for the fourth, 2, and then 1. So it's 6 times 5 times 4 times 3 times 2 times 1, or 6 factorial, which is 720. Here you have 8 horses running a race, assuming no ties. How many different ways can these finish as first, second, and third? So there's 8 horses that could finish first, 7 second, 6 third. So it would be 336 different ways. Now notice it asks the question, what is the main difference between example 1 and example 2? Well, in example 1, you're choosing all the elements, right? All the letters are going to be ordered. Whereas in example 2, you're just choosing some elements. So the number of permutations depends on if you're choosing all or some. If you're choosing all, then it's just n factorial. But if you're only choosing some, then it's n factorial over n minus r factorial. That is how you get the number of permutations taken a certain amount at a time. So in how many ways can 8 children line up in a row? Well, all 8 children are participating, so that means it's 8 factorial, which is 40,320 different ways. Now for number 2, 12 cyclists are competing in a race. How many ways can the cyclists come in first, second, and third? So that's 12 permutation 3, which means it's 12 factorial over 9 factorial. So 12 times 11 times 10 gives you 1,320 different ways. And number 3, a coin club has 5 members. How many different ways can there be a president and vice president? So you're only choosing 2. So it's 5 permutation 2. And the order matters because president is different than vice president. So it's 5 factorial over 3 factorial. It's 4 times 3 factorial over 3 factorial. So it gives you 20 different ways. All right, for the next one, the next type of ordering is combinations. This is when the order does not matter. And the example here is, think of a pizza. It doesn't matter what order the pizzeria puts the toppings. And we're not talking about the cheese and the sauce. We're talking about like the sausage and the mushrooms or the pepperoni. All right, the order that gets put on doesn't matter. It's just that it's on the pizza. So that counts as one pizza. For combinations, think of the binomial coefficients that we've talked about earlier. That's NCR, that's n factorial over n minus r factorial times r factorial. Because the order matters, the order doesn't matter, that's why you have the extra r factorial there to eliminate all the repeats. So there's going to be more permutations than there are combinations if you have the same parameters. So in example 1, you have 20 toppings for a pizza. To choose from, you only get to choose 3. So how many different pizzas can you make if you took 20 toppings and you only chose 3? So that's 20 factorial over 17 factorial times 3 factorial. 19 times 18 times 17 factorial over 17 factorial times 3 factorial. So 3 times 2 is 21. So the 17 factorials cancel out. 3 goes into 18, 6. 2 goes into 6, 3. So 20 times 19 times 3 will give you a grand total of 1,140 different ways that you could make those pizzas. For example 2, how many different ways can 3 letters be chosen from A, B, C, D, E? The order doesn't matter, just that they're chosen. So you have 5 letters and you're choosing 3. So it's 5 factorial over 2 factorial times 3 factorial. So that's 5 times 4 times 3 factorial over 2 factorial times 3 factorial. Cancel out the 3 factorials. 20 over 2 is 10. So there's 10 different ways that you can order those. Some other problems involve playing cards. So make sure you look at the different things that are involved when you have a deck of cards. Like there's 52 cards in the deck. There's 4 suits: clubs, diamonds, hearts, and spades. Clubs and spades are considered black cards because they're black, and diamonds and hearts are considered red cards. And since there's 4 suits, 52 cards, you divide that. There's 13 cards in each suit. And the cards are ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you get jack, queen, king. And these are face cards because they have pictures on them. So a standard poker hand consists of 5 cards dealt from a deck of 52 cards. How many different poker hands are possible? So you take 52 combination 5. So that's 52 factorial over 47 factorial 5 factorial. So you have 52 times 51 times 50 times 49 times 48 times 47 factorial, all over 47 factorial times 5 times 4 times 3 is 1. So you cross out there. 5 goes into 50 10 times. 4 goes into 48 12 times. 3 goes into 12 4 times. 2 goes into 4 twice. So if you multiply that out, you get 960 hands. So that's how many poker hands you can get that are possible with that deck of 52 cards if you get 5 at a time. Number 2, forming a 12-member swim team with 10 girls and 15 boys. The team must consist of 5 girls and 7 boys. So basically, you have to take how many different ways can you get the girls and multiply it by how many different ways you can get the boys. So from the 10 girls, you're choosing 5 times from the 7 boys, you're choosing, from the 15 boys, you're choosing 7. So when you find those and you multiply them, you get 1,621,620. And yes, there are ways to do this combinations in your calculator on the TI, and so that's okay as well. For a certain experiment, 4 students are randomly selected from a class of 20. How many different groups of 4 students are possible? So you have 20 students, and you're choosing 4. So that would give you 4,845 different groups. And number 4 here is like number 2, where you have a 10-person committee and there's 9 women and 12 men. So that you choose from, the committee must select 5 women and 5 men. So of the 9 women, you're choosing 5, times of the 12 men, you're choosing 5, and you get 99,792 different committees. All right. So that concludes our video for the counting principles. If you have any questions, please feel free to ask. Otherwise, I will see you in class. Have a good evening.